In this demo, we will add searching functionality. We're going to accept a search query, and we're going to return all cities for which one of the string fields contains the search query. First, we need to ensure that the search query can be passed in. That means adding a search query string to our action parameter list. We do need to combine this with filtering. A consumer might search, filter, or combine both. So we're going to pass through that search query to the same getCitiesAsync method on our repository as we used for filtering. Let's add that parameter to the repository contract and to the repository implementation. The first thing to do is change the null and whitespace check here. Only when both input parameters are null or whitespace should the full list of cities be returned. There we go. Then a few things can happen. It could be that we only have to apply the filter, only the search query, or both. We want to cover all of these. So the first thing I will do is cast the citiesDB set to an iQueryable of city. Like that, we can work on that collection, adding where clauses for filtering when needed and for searching when needed. There's a good reason to write our code like this, and it has to do with deferred execution. We'll get to that right after this demo. Let's add our filter first. So, if our name isn't null or whitespace, we trim it, and we apply a where clause to our collection to start from. Then let's implement the search. How we search depends on your architectural requirements. Often this is a full text search with the help of full text search components like Lucene. But it can also be much simpler. In our example, we will use a where clause again, which will return any author for which name or description contain the search query. We add a null check on description to avoid null reference issues. Lastly, we return the collection after ordering it and after calling to list async on it. And we can get rid of this unreachable code here from previous demo. Alright, let's give that a try. Seeing we changed the method used for filtering, let's start with applying a filter. And that still results in the same result as the previous demo. Then let's add a search query. We're going to search for all cities that contain the as part of one of their string fields. And there we go. We've got Antwerp here, which contains the right before cathedral. Note that we do keep casing into account. So if we start the with an uppercase T, we get more results. This may or may not be what you want, depending on your use case, obviously. And let's see if we can combine both. So we are searching for the, and we are filtering on Antwerp being the name. That should result in one point of interest, and that is indeed the case. Just to make sure, let's check to see if this was all applied at database level as well. And as you can see from this command, that is indeed the case. Yet we could have written this in another way. We could have just fetched the filtered cities from our repository and then applied our search to the list that would have been returned. Then you'd get something along these lines. And this would work as well. I sometimes come across something like this, but it's actually a very bad idea. This would result in first fetching all cities with the pass-through name as name from the database, after which that list would be searched in memory. That potentially means that a lot of unnecessary cities are fetched from the database. Our code, on the other hand, resulted in the full query, which means searching and filtering combined, being sent to the database and only the matching cities being returned. It's a very important principle that enables this, building a query statement by statement and only executing it when you need it. And it's so important for your API performance that I'd like to spend a minute talking about it. I mentioned it before in this demo. It's called deferred execution.